Okay. Hello, everyone. This is Takashiko with me, and I will present the audio signal flow framework on Spresense with NuttX. Um, but just before my presentation, let me introduce the just the surface of the Rev 2, the lunar journey of the NuttX. So, the NuttX operated on the moon without any problems. That's a great thing. Yeah, the NuttX, great NuttX. And Rev2 it uses Spresense actually, and it runs on the moon or performing the image recognition on Spresense and successfully transmitted JPEG photo to Earth. And this means NuttX works on the moon without any problem. And actually, the NuttX version is used at this time. It was 7.22. Yeah, a bit old, but the space things is takes a long time, so it's a usual thing, I think. And about the Rev 1 and Rev 2, so the three spacecraft carried Rev 1 and Rev 2 and split them on the moon. And these Rev 1 and Rev 2 is a robot standalone walking on the Earth, on the moon. And Rev 1 is moving, just hopping, jumping on the moon and the faced on their net the antenna to the Earth. And Rev 2 is split sphere as a tire, a kind of tire, and look at the searching the Rev 1 by the camera and the image recognition. And if Rev 2 find Rev 1 and then turn around in the center of the Rev 1. Yeah. And this is an actual picture taken by Rev 2. So that means different is worked of the NuttX video framework, actually. And by the way, the Spresense used in space actually predated Rev 2, which was used for satellite orbital mission in 2018. It was a satellite on around the Earth. And this picture is the actual picture taken by the Spresense on satellite. So right now, the Spresense is utilized in space with, NuttX is utilized in space with Spresense. So yeah. Anyway, the NuttX is very endurance for using the tough situation like in space. So that's great things. Thank you for providing the great OS operating system. Anyway. Okay, so go back to my presentation, and today's agenda is like this. What we want to do for this framework, and I will introduce the structure of the audio framework and application code using this framework, and contribution plan. Okay, so what we want is there are four purposes I have, and one is make each audio signal processing block independent and reconfigurable at runtime, and create a program model that is intuitive and easy to understand in the application code, and easily add new signal processing component by a user, actually by a application programmer, and make effective use of the Spresense 6 cores. So, for example, there is a kind of the requirement like apply FFT from audio input to AI for sound recognition, and at the same time store audio input data to the SD card or send it to the network. So when AI recognizes something, many people complain that they want to know the validity of the recognition result. In addition, the original data is indispensable to make AI rerun. For this result, such cases are very common, I think. So that example, the block diagram is like this. Of course, it's very simple. The audio data is initiated on audio input, like a microphone. And after that, the data is going to the FFT and the AI. And in parallel, it will be the file saved to the file or sent to the network. So build a framework that allows for institutive programming of such structures. That is the purpose. And this is a basic design of the structure of the framework. The basic unit is a block called component that processing the voice data, actually sound data signals, and components are connected to each other to achieve the desired functionality. Each component has an input node and an output node, and this and the input and the output can be connected, actually bind to each other. The output can be connected to the multiple inputs. Components include a source component that provide the voice data, and a sync component that serves as an endpoint of the voice data, like this. And about the data flow, so audio memory is acquired via dedicated allocator. The memory has a reference counter, and when the reference counter reaches 0, the memory is reached to the allocator. It's a simple, usual reference counter things. And the source get the memory from the allocator, create and capture the data, audio data, and then pass it to the later component. And intermediate component processes the incoming speech data from the input node as needed, and flow the result to the later component via the output node. The terminal component is received the data and such as play to speaker, and then release the received memory. At this time, if other component are using the this memory, of course the reference counter is not 0, then the actually the keep using on the other component. So the structure is like this. And handling the audio data on in component. So when the data arrived at the input node, each component calls its member function on data. On data, audio data is acquired by the pop data and processing proprietary and then pushed to the output node by push data. And if user create a component that perform its own signal processing, it inherited the component and override just on data. And handling the system message. So when the audio play or recording is run, the processing is executed asynchronously. So error or such kind of the status changing notification that occurred during the execution are notified to the user asynchronously via the event listener. So, and offload to Spresense other CPU. So with this structure, the operation in the audio component independent. So, and it can be offloaded to another core in Spresense, like this structure. So now that is the structure of this framework, and from now I will show you the sample code, what how much easy for using this framework. So right now, that code is in Spresense GitHub. Later on, I will explain the contribution plan. So this example is to target to create this structure, get the mic input, and just display the data. It's emulate kind of the signal processing. Just this one is just an example. So just show some print some audio PCM value and audio output to speaker. So this one is just audio through things. And on the initiator, the source of component, it needs a memory allocator. So I add the memory pool for other allocation. So this is user original sample like this. And just override on event, then the user can get any notification from the audio framework. And create instances, and audio input and the output, memory pool, and the middle component, which is user original. And set up the parameters. It is just this system is using the 48 kilo sampling rate and 16-bit sample, and 2 channels. And set the event listener on the system. And after that, create a memory instance. So 4K byte and 8 tiles memory pool is created on this code, and set the memory pool on the audio input component, and then bind the components like this. So now audio input display data and audio output. So these three is binded like this. And just after that, then just start it. Then it can be worked. So this one is implement of the original audio component. So as I explained, just inherit the audio component and override on data method. Then you can focus on implement signal processing, pure signal processing after getting the audio data. So this one is a total source code of the audio signal, the audio through. So without comments on example code, very short, you can see. So I think that is much more instituted code. So that is what we want to do. And now about the contribution to the upstream. So currently, this framework is only available in the Spresense SDK Spresense repository. There are two reasons for this. One is currently the NuttX audio driver for the Spresense is not enough for supporting this framework. We need to update, and now we under contribution and the PL. So after this PL is merged, then we will start to contribute this framework to the NuttX. And secondly, there are some components offload processing to another CPU, and there are dedicated to Spresense. Example, for example, MP3 decoder is run on the other CPU. So, this is just specific for the Spresense. So for first, we will address the PL 1 point and merge them. And for second, we plan to finish the work by summer and implement the PL including the framework. So yeah, that is a plan. So yeah, this is a summary. We built all this processing framework, and what we want to do is four things I explained, and all done by this framework. And the contribution to upstream will also proceed. That so thank you for the attention.
Thank you, Vincent.
Do we have any questions from the room?